Okay, for graphing, remember, we can do pretty much almost everything in our calculator except for log base, like a 4, a 5. You can do e's, we can do any exponential, and then you can do log base 10 and the natural log. So for this one right here, y equals 2e to the x minus 1 minus 3. First we have to state the domain and range. We got to label 3 points and the asymptote. So for domain here, it's an exponential function. Remember that the domain of an exponential function is all real numbers. And the range typically would be y greater than 0. This shifts down 3 units, so y is greater than -3. Again, since it's shifting down 3 units, the asymptote, which is usually a horizontal line here, is also going to shift down 3 units. 1, 2, 3, and we draw that right there. Now it says to label, and so we are going to have to label this, the horizontal line, y equals -3. Then I'm just going to go type this function here into my calculator. We're going to go 2e to the x minus 1, close the parentheses, and then subtract 3. Now I want to go to my table, and I want to plot some points. Now 1 comma -1 looks like a really good point to pick, so I'll choose that one. Don't forget to label 1 comma -1. I'm going to choose 0 comma -2.264. 0 comma -2.2-ish is right there. I'm going to draw a line right there. 0 comma -2 point, and again it was 264. And then the last point I'm going to choose, it will be, I'm just going to pick here, 2 comma 2.4. 2 comma 2.4, so that's about right there. And I'll label that one as well, 2 comma 2.4. Do not forget to label, or otherwise you won't get full credit. Hugs the asymptote, hits the points, and then starts skyrocketing upward. That's why they call this exponential growth. There we go. State the domain and range, label 3 points, we label the asymptote. Okay, now this is a log base 4 function. So what we're going to have to do is we're going to have to make a couple tables here. And I don't really have a good place to make these tables. I suppose that I'll just choose right here, up here to begin with. I'll choose up here, and we'll go from there. Now, I should state my domain and range before I begin. So remember, domain for a log is x greater than 0. We're shifting up 2. And that's not going to affect left or right. So domain stays x greater than 0. That would affect the range, but the range for a log is all real numbers. Okay. Now, since we didn't shift left or right, we still have our vertical asymptote right here along the y-axis, and I'm going to label that. That is the line x equals 0. Okay, so now we have to say, all right, I can't plug this into my calculator. We got to make a table. How do I choose what numbers for x? And again, you look at your base. Remember, it's 1 over the base. The base is 4. Choose the number 1, choose the base. That's what you have to keep on telling yourself. 1 over the base, 1 and the base. And the log base 4 of 1/4 is -1. The log base 4 of 1 is 0. Log base 4 of 4 is +1. But that's not what we want. This is shifting up 2. Upward shift affects your y values. So we're going to take all of those and we're going to add 2. If the x plus 2 was in parentheses, then I'd be subtracting 2 from x because that would have been a shift left. So any shift left or right, you're adding or subtracting x. Any shift up or down, you're adding or subtracting y. And so the new table that we get, x, y, is going to be the 1/4 doesn't change, the 1 doesn't change, the 4 doesn't change, but the -1 plus 2 is going to be +1. 0 plus 2 is 2, and 1 plus 2 is 3. And those are the points I'm going to plot. 1/4, comma 1, and we should label that 1/4, comma 1. 1 comma 2, label that, 1 comma 2, draw an arrow if we have to, and then 4 comma 3, and label that point, 4 comma 3, there we go. And so our graph hugs the asymptote here, doesn't go beyond the asymptote, and then hits that point, and it doesn't skyrocket, but it does keep going up. 1 over the base, 1 the base. That's what you have to remember. Okay, g of x is the natural log of x plus 2. Domain for our natural log function, typically x greater than 0. This, because of the plus 2, goes left 2 units. And so our domain is x greater than negative 2. 2 units to the left of 0 is negative 2. That also means our asymptote is going to be shifted left 2 units. I'll go ahead and put that on there. And that is the equation x equals negative 2. Range for logarithms never changes. All real numbers. Now, because it's a natural log function, we can use our calculator to get us some nice points here. Clear that. We're going to have the natural log of x plus 2. The plus 2 is inside the parentheses, and so I type it as so. Look at a table, and we get some good values here. 0.69, negative 1, 0. There we go. 0.69 right here, and I should be labeling these points, and I will. And then 1 comma 1.09, which is going to be around right there. So we'll label this guy right here. Negative 1 comma 0, excuse me. There we go. Negative 1 comma 0. This point right here was 0 comma 0.69, and this point right there was 1 comma 1.09. And so hugs the asymptote, hits the points, and goes off. Okay, the last one is log base 3 of x minus 1. Domain would be x is greater than 0, but for this we shift right 1 unit. And so domain becomes x greater than 1. Put the asymptote and label that asymptote. X is equal to 1. Range for logarithm, all real numbers. We make our 2 tables, one for log base 3 of x. So we choose 1 over the base, the number 1, and the base. Log base 3 of a third is negative 1. Log base 3 of 1 is 0. Log base 3 of 3 is 1. Now, since we're shifting right 1 unit, that means to all my x values here, I have to add 1. Again, it's because it's a right shift. I know it says minus 1 in there, but that goes right. And to go right, you have to add 1. So this becomes x, y. The y's don't change. Negative 1, 0, 1. 3 plus 1 is 4. 1 plus 1 is 2. And I know that 1 plus 1 is a third, but if you didn't know that, you can come over here. 1 plus 1 divided by 3. Hit enter. And as I said, 1 and a third. So we're going to plot those points. 1 and a third, comma negative 1 is about right here, and I want to label that. We have 2 comma 0. And then we have 4 comma 1. And we draw our graph. Okay, and that's it. So study tonight. Best of luck tomorrow. Again, you really, really want to know all of these here. You need to know your domain and range for exponential and logarithmic, and you need to know your a equals p times e raised to the RT.